Hi everyone, today what we're going to talk about is greatest common factor and the factoring trinomial of the form ax squared plus bx plus c, where a does not equal to 0. It's very important because the a is now we are talking about. That means there's a number in front of it, and the same process still works the same way. A quick refresher, a quadratic equation is a polynomial of a second degree, usually in the form of fx equals ax squared plus bx plus c, where abc is an element of a real number and a does not equal 0. Every quadratic equation has two values of unknown variables, usually known as roots of the equation, and we are getting there. The roots of the quadratics are x-intercepts. The roots of a quadratic equation can be obtained by factoring the equations. We are going to finish one more factoring situation, and then we're going to go into solving for roots. The first thing is a factor trinomial of a form ax squared plus bx plus c, and a does not equal 0. Today, last lesson we did with x squared only have a leading coefficient of 1. Now it's 2 or any other number. So what we're going to do is with the same process, we also have a combination for the front, and we're going to match the front combination and the back combination to get the number in the middle. 2x squared, we are going to write down the factors, and that's going to be 1 and 2, and that's the only combination. And 6 has 1 and 6 and 2 and 3. Now the thing is, we want to get to 7, and pretty cool is you can see it right away. 1 times 2 gives you 2, and 2 times 3 gives you 6. But if you cross that 2 times 2 like what we did, that's 4. And then 1 times 3, that's 3. And when you add them together, it's 7. The process is the same, except the only thing different is now we have the number in the front we have to worry about. And because this one, if you have 4 plus 3, e is equal to 7, therefore the middle term is checked and the last term is also checked. 2 times 3 right here. Number 6 is checked right here. Here is the tricky part. Remember, I made such a big deal about you writing your n sideways. Sideways means this way in pink. Answer should be x plus 2 sideways and 2x plus 3. And then so I want to write it here. Maybe you can see it. That's 1x plus 2, and then right there. And that is all for the factoring. Compare the difference between this lesson and the lesson before. Let's try one more on the other problem. So example number 2, let's break it down. It has a little bit more combination, 1 and 15, 3 and 5. And this one's 1 and 14, 2 and 7. Now, which one will give you a possibility of 41 in the middle? If I go 3 and 5, 7 on top, that will give me 35. And if I put the 2 on the bottom, that will be plus 6. So 3 times 2 is 6. 5 times 7 is 35. And then when you add them together, 41. And you are done. And the answer is going to be 3x plus 7 sideways and 5x minus plus 2. Alright? Now, some of you guys will ask, but Ms. Wiesman, is it possible to have different combination that gives me the same parenthesis? Absolutely not. So your number has to match up correctly, or something is going to be wrong with the sign, or something is going to be wrong with the way the parenthesis is written. There's only one combination to give you an answer. Now, if you don't find any combination, that's actually called prime. So you need to make sure you double check all your combinations. So that's number 2. Number 3, you have 15x squared minus 13x plus 2. So break it down. That's 1 and 15, 3 and 5. And right here is 1 and 2. Now, what's the possibility of giving the 13 in the middle? The number can be flipped also. And if you can see it, I could do 3, 5, 2, 1. Oh, there's 10. Can you have both negative? Yes, you can definitely have both negative. The reason for that is 3 times 1 is going to give you a negative 3. And then 5 times negative 2 is going to give you a negative 10. Or if you want to, you can just do 5 times 2 is 10. 3 times 1 is 3. But I need a 13. So both of them have to be a negative sign. And that will give me negative 13. But if I made the bottom here negative, that means that I need to transfer this one with a negative, because it's going to be 3 times negative 1 give you negative 13. And the top also have to have a negative sign. And then if you double check, is your negative 2 times negative 1 gives you a positive 2. And in this case, that is yes. So your answer is done. 3x minus 2, 5x minus 1. There's your answer. All right. I would like you guys to try number 4 yourself and check your answers. The answer for example number 4 is 2x minus 5 and 3x plus 1. Example number 5 is a little different. Example number 5, if you notice, is only 2 terms compared to the other one's 3 terms. But example number 5 can also be done the same way as the 3 terms. I would like you guys to think about this compared to the ax squared plus bx plus c. We are talking about we only have the ax squared term and the c term because the one that's in the middle with the x term is missing. So if you want to, you can actually say this is 4a squared plus 0a minus 9. Now factor. And then if you do that, you can do 1 and 4, 2 and 2. And this is going to be 1 and 9, 3 and 3. And then you should be able to see it. Oh, they have to be exactly the same. It's prime because there's no way you can have 2a squared plus 0a minus 25. There's no way you can have combination come out to be a 0 term in the middle. So therefore, it's prime. And there's nothing you can pull out. So therefore, it's done. One of them positive, one of them negative. To get my sign in the middle to be gone. So because this is negative 6, that is positive 6. So that's going to be 0. And you should be able to remember that's going to be 1 positive, 1 negative. So it's going to be 2a minus 3 and 2a plus 3. Now there's actually a formula for that. Alright. It's called difference of a square. Now the reason is the difference is because the difference word right here is talking about the sign. Square is going to be based on square root of 4 is 2. So it's 2 times 2 give you 4. Square root of a square, that's a times a. 9 is 3 times 3. So that's why everything is a square. Therefore, it's called the difference of square. And if you want to, you can actually double check every single time. There's a formula goes like this. The formula goes a square minus b square. So that's the same form we have right here. I'm going to erase all the stuff. So if you erase all the stuff, you can tell that's really 2a squared minus 9. And that's going to give you a minus b and a plus b. And that is going to be the problems that's in that form. If you can square root every single term, and the middle term is a minus sign, you can square root every single term. You can square root every single term, and the middle sign is a negative. You can do this every single time. Okay, I hope that helps on the explanation, a difference of square, and then here's the formula. Alright, then going on to the next one, example number 6. Example number 6, when you look at it, you guys would think, say, oh, is that the same thing as example number 5? And I'm going to tell you that's no, because remember, difference means minus sign. I have a plus sign here. See that? Because this is plus. It doesn't work. There's no way you can find a combination like the ones we did with the crisscross. The reason for that is, let's write this out. M squared plus 0m plus 16. You can do 1 and 1. This can be 1 and 16, 2 and 8, 4 and 4. Oh, you say, oh, there's a 4 and 4. So 1 and 1, 4 and 4. Since it's positive, you either have to have the 4 both to be positive or both to be negative. You cannot have one positive, one negative. So if I have both positive, that's negative 4, and that's negative 4, that's negative 8. It doesn't match. If I have 1 and 1, positive 4, that's going to be 4, and that's going to be positive 4, and that's going to be 8. That is no way you can get a 0. You cannot try 2 and 8. 2 and 8 will never give you 0 either. So because this is a situation that no way we can have a combination, it's actually called the prime. This cannot be factored. Number 6. Alright, you guys try number 7 and let me and check back with your answer. Example number 8. Example number 8 is called factoring out a monomial GCF first. I know we talk about with the things pulling things out they have in common. So if we draw the L, we can look at it. I can pull out, there should be a square right here. We can pull out a 4. 2. Let's start with 2. 20x to the third minus 34x to the second plus 12x. That should be 6x. Then you can pull out an x, actually not 2. So that's 10x to the third minus 17x squared plus 3. Then x. Then you can pull out x, and that's going to be 10x squared minus 17x plus 3. Now, so you have 4x, because 2 times 2 times x is 4x, and then you have 10x squared minus 17x plus 3. Now, you should double check and you factor the 10x squared minus 17x plus 3. So let's see, I have 1 and 10, 2 and 5, and this is 1 and 3. Oh, there's a possibility. Okay, so if I do 2 and 5, 3 and 1. 5 times 3 is 15. 2 times 1 is 2. If I make both of them negative, but does it match the 3, which is a positive? Well, negative 3 times negative 1, it is positive 3. So that one is also checked. Alright, so now to write your answer, you need to be careful. Again, don't forget to write the answer sideways, and your answer is going to be 4x times 2x minus 3 and 5x minus 1. Again, the answer has to be written sideways. So the answer for example A is 4x times 3x minus 3, 4x times 2x minus 3 times 5x minus 1. So go ahead, give example number 9 a try and check back with your answer. Example number 9, the answer is 2y times ay minus 3 times y minus 6. Some of you might have question, which hairs to use. When I look at the number in the middle, I notice it's a negative 51. So I'm going to try to look for the combination will give me that. If I use 8 and 18, that would be way too big because 8 times 10, 8 times 18 is close to 20. 8 times 20 is almost 160. There's no way. So I'm looking for the combination. And I notice, hey, if I do 8 times 6, that's 48. I might have a possibility somehow get to a 3. So that's why I tried. And that's how I get my answer. All right. And that will conclude today's notes. Thank you so much for watching.